The various parts that we used were two Arduino Uno microcontrollers to control the whole mechanism, an 16:2 LCD display, around 5 push buttons to control what cookie you want, some LEDs, 3 stepper motors attached to 3 coils that we made by hand, and this is built using the Tetrix kit and is connected to 2 servo motors, which is basically just a platform to push the cookie below. And that's the NXT kit to control the 2 servo motors there.
Specifically spamming this video.
This is a servo control platform, and this is being controlled by an NXT Lego kit. This is the brain of NXT Lego kit, and these other parts are from the Tetrix kit, robotics kit basically. This is a 12 volts battery. This is DC motor control, servo control, switch, touch sensor. Input is either 0 or 1, and the circuit goes like this: battery to switch to DC motor to servo to the servo controller to servo, and then back to the brain of the Lego NXT kit. Basically, the input is provided at touch sensor. It receives either 1 or 0 depending on which the servo motor either lowers itself by lowers its floor or comes back to 90 degrees.
So this is the menu we use to select what kind of biscuits we want dispensed. Basically, these are just ordinary push buttons that we've connected to the Arduino using a standard configuration. It's just that we used a combination of delays to give it a sort of toggle operation so that we can select or deselect an ingredient upon push. We use these 3 buttons to select which biscuits we want, and as you can see, they can be toggled however we want, and we use this button to start the mechanism off like so, and we use this button to stop, and this light lights up at the end of the process, after which we have to reset for the next order.
This is the 16:2 LCD display that we use to display the ingredients and the name of our project. This is the potentiometer that we can use to control the contrast of this display. The input is fed serially through the Arduino Uno microcontroller, and we also use the LCD library to do the coding part.
So here we have the code of our project, which is basically the Arduino that drives the 3 stepper motors through the L293 DNE drivers. Basically we have about 3 blocks of 4 Arduino output pins mapped to each stepper motor through the driver, of course. We have 4 output pins per motor, each of which correspond to one of these motor drivers. These are basically dual H bridges which modulate our output and make it usable for the stepper motor, in the sense we supply pulses through the Arduino and according to which direction we wanted to move and how we wanted to move or not. And it's basically modulated by the dual H bridge and supplied to the stepper motor. And we need this bridge because, well, without it we probably would not get the required amount of current to operate these stepper motors. And when the stepper motors do start off, they have a fairly nasty induction coil kickback that might possibly damage the Arduino because of voltage spikes that are completely unwanted. So now we'll see the operation of the machine from beginning to end. So let's say we want a Mari biscuit, which is in the middle row, as you can see over here. We head over to the menu system and we select the middle button, and when we're ready we press go. It starts off the system over there. That's one. And press this button, which stops the light away. And to collect the biscuits, we go to the slide and there we go.